I welcome you once again to this training. This lesson video covers calculating concentration of a standard solution. It is presented by Emmanuel Izwane. Please get your pen and book ready. Let's begin. Calculating concentration of a standard solution. First, we have to know is concentration. This is the amount of solutes contained in a given volume of solution or solvent. When you consider volume of solution, then the concentration is regarded as molarity. But when the volume of solvent is considered, the concentration is referred to as molality. Concentration is determined in mole per dm cube or gram per dm cube. However, our study at this level is based on the volume of solution, which is molarity. Therefore, molarity can be defined as the amount of solutes contained in a given volume of solution. The unit is m or mole per dm cube. The m is a capital letter. We have different concentrations: mass concentration and molar concentration. When the amount of solute is determined in mass, the concentration will be called mass concentration. Therefore, mass concentration is the mass of solute in 1 dm cube of solution. For example, 10 gram per dm cube, 15 gram per dm cube. You can have 1 gram per dm cube, 1.5 gram per dm cube. You must have seen such values before now. What it means, for example, 10 gram per dm cube. It means that 10 gram of the solute is dissolved in 1 dm cube of the solution, not of the solvent. Okay. We have molar concentration measured in mole per dm cube. When the amount of solute is determined in moles, the concentration will be called molar concentration. Therefore, molar concentration is the number of moles of solute in 1 dm cube of solution. For example, we can have 0.2 mole per dm cube, 0.5 mole per dm cube. However, you cannot measure mole of the substance in the lab directly, so you need to measure the mass and convert it to mole using this formula below. Mole equal to mass over molar mass. Hope you can remember how to calculate molar mass of a substance. Okay. Formulas involved in this calculation: equation 1 molar concentration is equal to amount in mole over volume of solution. The unit is mole per dm cube. Equation 2, molar concentration is equal to mass over molar mass times volume. The unit is mole per dm cube. So the volume must be in dm cube. However, they might give you the volume in cm cube in the problem, and you were expected to convert it to dm cube. To convert cm cube to dm cube, you divide the cm cube value by 1000 to get a value in dm cube. Example, convert 100 cm cube to dm cube. Solution, 1000 cm cube equal to 1 dm cube. 100 cm cube equal to x. Cross multiply and make x subject of the formula. So we have x equal to 100 divided by 1000. This is the most important conversion step here, where you have to divide the cm cube value by 1000. So this gives us 0.1 dm cube. Equation 3, mass concentration equals to mass over volume in dm cube. The unit is gram per dm cube. Worked examples. Example 1, calculate the mass of sodium triosocarbonate 4 required to prepare 250 cm cube of 0.15 mole per dm cube solution. The relative atomic mass of element is given. Sodium equal to 23.0, oxygen is equal to 16.0, and carbon is equal to 12.0. This is a WAEC question, WAEC 2012 practical. Solution, you check the units of the concentration you are asked to prepare. Over here, the unit is mole per dm cube. Again, you consider other quantities in the question. You can see that volume is given in cm cube. The name of the substance is provided, and the relative atomic mass of each constituent element is also given. So we can now write the formula we can use to solve this problem. We shall use equation 2, which says molar concentration is equal to mass over molar mass times volume. After that, you write out the value of each quantity in the formula. we can start by writing out the molar mass. So the molar mass is equal to 106 grams per mole. We need to show the solving. It is done by adding the relative atomic mass of the constituent elements together. As we can see here, the molar mass of Na2CO3 is equal to 23 times 2 plus 12 plus 16 times 3. That gives us 106 grams per mole. The 23 is relative atomic mass of sodium. The 2 is the number of sodium atom present in the compound. 12 is relative atomic mass of carbon. There is one atom of carbon in the compound, so 12 times 1 is equal to 12. The 16 is for oxygen, and the 3 there is the number of oxygen atom present. Note, once you are given the name of the substance, they may or may not give you the relative atomic mass of the constituent element, especially in JAMB. Therefore, you are expected to know the molar mass of the substance given with the name. So we continue to write out the values of each quantity in the question. So next one is volume. Volume is equal to 250 cm cube. Then we convert it to dm cube. We convert it to dm cube by dividing it by 1000. So 250 divided by 1000 will give us 0.25 dm cube. Next is molar concentration. It's also given in the question. Molar concentration is equal to 0.15 mole per dm cube. The mass is unknown. Therefore, you make mass the subject of the formula. Mass is equal to molar concentration times molar mass times volume. So we have that mass is equal to 0.15 times 106 times 0.25, which gives us 3.98 grams. It means that we have to weigh 3.98 grams of sodium triiosocarbonate 4 and dissolve it in 1 dm cube of solution using a volumetric flask. Note, in chemistry, Any answer derived from calculation must be reported in three significant figures: the unit of the quantity calculated must be reported with the answer. Example 2. A 0.800 gram of anhydrous sodium carbonate is dissolved and transferred to a 150 cm cube volumetric flask and made up to the mark with distilled water. What is the concentration of the solution prepared in mole per dm cube? Solution. Again, you check the unit of the concentration you are asked to prepare. We are asked to prepare the concentration of the solution in mole per dm cube. So we write out the formula that we can use to solve this problem. And again, we're going to use equation 2, which says molar concentration is equal to mass over molar mass times volume. So we write out the values for each quantity in the formula. Again, we start with molar mass. Our molar mass of the compound is 106 gram per mole. Remember to show the solving. Volume is equal to 150 cm cube. Again, convert the cm cube to dm cube by dividing the value by 1000. So we have 150 divided by 1000 gives us 0.15 dm cube. Our mass, which is also given in the question, is 0.800 grams. The molar concentration is unknown, so we have that molar concentration is equal to 0.800 over 106 times 0.15, which gives us 0.0503 mole per dm cube in three significant figures. Let's take a little classwork. A 0.800 gram of anhydrous sodium carbonate is dissolved and transferred to a 150 cm cube volumetric flask and made up to the mark with distilled water. What is the concentration of the solution prepared in gram per dm cube? I'll give you a little time. You're expected to pause this video and continue after you have solved this problem. Okay. The answer is 5.33 gram per dm cube. Did you get it? Good. You used equation 3, right? Okay. Let's continue. Mathematical relationship between molar concentration and mass concentration. Molar concentration is equal to mass concentration over molar mass. Mass concentration is equal to molar concentration times molar mass. For me, once I remember the basic formula in chemistry, which is mole equal to mass divided by molar mass, then remembering this relationship between molar concentration and mass concentration won't be a problem. All I need to do is to write mole to molar concentration and change mass to mass concentration. From this relationship, if you are solving for molar concentration with mass conc given, you have to divide the mass conc by molar mass. Again, if you are solving for mass conc with molar conc given, you have to multiply the molar conc by molar mass. What it means is that the numerical value of mass conc is always higher than the value of molar conc. We have come to the end of part 3. Thank you for being here, and I look forward to seeing you again in the next part. Bye.